Hello! With this video, we begin the series on 4 benzodiazepines: diazepam, lorazepam, midazolam, and clobazam, with emphases on its application in the treatment of epilepsy. The series includes an introductory video. This video, videos about retrosynthesis, and about the resulting syntheses. Next, we present the structural characteristics for the 4 drugs, including systematic names, CAS numbers, structures represented in 2 and 3 dimensions. Diazepam is a 1,4-benzodiazepine, in which the methyl attached to the nitrogen at position 1 stand out. In lorazepam, the hydroxyl group stands out. In midazolam, the fused imidazole heterocycle stands out. In clobazam, it is notable that, unlike other benzodiazepines, it is a 1,5-benzodiazepine. We can say that this class of drugs was discovered by chance, as initially there was interest in quinazoline derivatives of the general formula shown here. However, when reacting, the methyl chloride shown with methylamine, instead of yielding the expected quinazoline, it produced chlordiazepoxide, a benzodiazepine that turned out to be a compound with interesting pharmacological activity. From the discovery of chlordiazepoxide, a large number of benzodiazepines were created, which, from the point of view of epilepsy treatment, stands out diazepam, lorazepam, midazolam, and clobazam, which, unlike the previous ones, is a 1,5-benzodiazepine instead of a 1,4-benzodiazepine. Benzodiazepines increase the activity of GABA, a neurotransmitter considered inhibitory when interacting with the GABA-A receptor, to modulate neuronal hyperactivity and thus prevent seizures. Regarding their structure-activity relationships, we can say the nitrogen of the diazepine ring can be bonded to alkyl groups, such as methyl. The methylene in position 3 can be oxidized. X and Y represent carbon and nitrogen atoms that can swap these positions to give rise to 1,4-benzodiazepines or 1,5-benzodiazepines. Fused heterocycles can be formed at positions 1 and 2. When Z is a carbon atom, it corresponds to an imidazole or a nitrogen to a triazole. Electron-withdrawing groups attached to the fused benzene ring at its position 7 increase pharmacological activity. Halides attached in the 2' position of the phenyl group also increase this activity. Here, the structural variations according to the mentioned structure-activity relationships are illustrated. Diazepam, lorazepam, and midazolam are included in the World Health Organization's list of essential medicines. The synthesis of diazepam was reported by Sternbach, introduced in Europe by Roche, under the brand Valium. Lorazepam was patented by American Home Products, introduced by Wyeth in Europe and in the United States under the brand Ativan. Midazolam was patented by Roche under the brand Dormicum, and clobazam was patented by Roussel, introduced in Europe under the brand Urbanil, and by Hext under the brand Frisium. The 4 drugs are indicated in the treatment of various types of epilepsy, notably status epilepticus, a medical emergency for which they are used. More frequently, midazolam, Diazepam, and Lorazepam. Additionally, benzodiazepines are used in the treatment of conditions associated with anxiety and panic, as well as sleep inducers. Diazepam and Lorazepam are administered through various administration routes in addition to oral. They have good oral absorption. Their common adverse reactions are shown here, and they have some rare ones that require medical monitoring. Midazolam can be administered by various routes in addition to oral. Clobazam has a long half-life, while that of midazolam is short. Common adverse reactions are shown here, as well as rare ones that require medical surveillance. Here are some relevant physicochemical properties for the 4 drugs. The resulting retrosynthesis and synthesis will be presented in the following videos. Thank you for your attention.